Hey guys, it's John Wilson, student number W1899954, and today I'm going to be talking about AI in minute by minute forex trading. Forex trade here. I'll show you here at the beginning. Introduction to forex trading and need for AI. Forex trading is the trading between two currencies, like the euro and the US dollar. In part A, I discuss the applications for forex trading, like machine learning for price prediction, deep learning, time series prediction, reinforcement learning, and dynamic decision making, like Q learning, etc. Natural language processing, sentiment analysis, like looking on Twitter, things like that. AI mode training and real time execution. In part B, I compared three techniques. These were linear regression, LSTM, and Q learning. I went through strengths, weaknesses, examples of application of use for each one. And here's a table that has like the basic information on, so it's quick. So you can see I decided to go with the LSTM network because I thought that'd be good for the temporal dependencies and complex non-linear patterns in the fast-changing forex market, because it changes a lot. It varies. It's not like steady increase or steady decline. So that's why I went with that. So here's my diagram of how it works. So get the data. We process the data, clean it, we train the LSTM, use to train it for price prediction, a simulation of the trades, and then a visualization on how well I've done. Here is my prototype here. As you can see, we have to install the required libraries first, and then pull out the parts from the libraries that I needed. Here's the API I used. I used Polygon.io to grab my data between the dates of the 24th of 9th/01 to the 30th, so a month of data. Here's that month of data. It's then normalized. I use as a min-max scaling to normalize the price to a range between 0 and 1, which helps the LSTM coverage faster during training. Create the sequences for LSTM, sequence length 60, which is like the past 60 minutes. So it looks at the past 60 minutes of data and predicts the next minute upon that information. Split the data into 80% learning and 20% where I'm going to do the trading simulation on. Here's what we built the LSTM model here. Two LSTM layers capturing temporal dependent dropout layers, preventing overfitting, fully connected layers predicting next price, compiles using model Adam optimizer, mean squared error loss function. Here's the training. We have batch size 32, epoch just 10. As you can see, it was training here, training, and it wasn't getting any better, it was getting worse, so we reduced the training rate here, as you can see. Then we evaluate the model here to calculate loss values. Here we use it to make predictions. Here we are visualizing the training and validation losses. Here we are. You see it goes down quite quickly and then semi-stabilizes here. And here's a visualization of the predictions versus actual prices. As you can see, it follows quite closely. This break here is for the weekend. The market closes on the weekend. And here's my trading simulation. We have our pip size. It's quite a small pip size. We take profit at 25 pips. We stop loss at 5, and we risk 1% of our balance in each trade. Here's when it goes into a trade, this is what happens. And then it prints out, when it finishes a trade, it prints out that it was a buy, the entry price, the exit price, results, the profit or loss, and my final balance for both. As you can see, it's done it here. You can see, yeah, the first one won, so if at 25, at 2, so it's 50. Here you can see the final result of 1,324. But we have final results and summary here. So trading summary, initial balance 1,000, final balance was 1,324.52. So we profited 324. Total trades 54, successful trades 14. So it had an accuracy of around 25.93%. Here's a visualization of the balance over time. As you can see, the first one won, then it looks like we lost a few. We lost quite a few here, and then it managed to sort itself out. Here's a visualization of all the buys and sells here. You can see here's where we lost a lot of money because there's a lot of market noise, so I didn't know whether to buy or lose. This is something that I would change in my next iteration of the code. I would try and mitigate market noise so that it would work a lot better. These are just this is just software testing. You know, you can just run these and they check if the dates. I did that in the code, but I've just put them here so that you can see them. So yep, as you can see here you can see, so the training loss is meant to decrease over time, but as you can see here, it didn't decrease. So this is why it's saying there's an error. It's not terrible that there's an error, but it just means that the training loss wasn't consistent the whole way through. Here's a visualization. We've seen that before. Yeah, this is all things we've seen before. Comparison of expected results. The training validation of predicted actual prices, trading and strategy accuracy. And then we have an evaluation of the results, the effectiveness. I thought that it was reasonably effective, but it was affected too much by market noise, and reducing its reactiveness to market noise, I think, would make it more successful. And yeah, look, we have our strengths here: trend to capture, profitability, generalization, looking at noise sensitivity, market volatility, overfitting risk, static strategy. And yeah, that's it. Thank you very much, and hopefully, well, if you have any questions, just let me know in the Viva. Thank you.